Hi guys, welcome to today's tutorial. We continue on a series of partial fraction, and at this point we are going to be dealing with partial fraction with quadratic factors. Now we have looked at partial fractions with linear factors, and linear factors are also repeated factors also. We have looked at that in subsequent in previous videos, so you can check out my other videos on that. You will find them on the channel. Today we are looking at, like I said, we're looking at quadratic factors. But the kind of quadratic factors we are going to be examining are quadratic factors that are not factorizable. Now we know that a quadratic factor has the highest power to be in the as 2. And in this case we have x squared plus 2. That's in our denominator. You get me now? So what we need to do is to there is a way we write out the expression of the partial fraction. Now we have x squared plus 2 and x plus 1. That gets me now. So the way we write out our expression for this, as a partial fraction of this kind of expression, is going to be ax plus b over x squared plus 2 plus c over x plus 1. So because we have a quadratic expression that is not factorizable, that what gives birth to this expression of our variables that we're going to be looking for later as we solve this particular question. So take note, when you have a question that has a quadratic factor that is not factorizable, this is going to be the expression of the numerator for that kind of denominator of the quadratic expression. Are you getting me now? So it's the quadratic expression that carries this particular variable. So for instance, if this variable comes after the x plus 1, let's say for instance we have it as 7x squared plus 5x plus 13 over x plus 1 x2 plus x squared plus 2. The expression here will be a over x plus 1 plus bx plus c over x squared plus 2. I guess me now. So it's always the expression that carries the quadratic factor or equation now, or expression that we carry this particular expression of the numerator. So I won't take note of that. Now, so let's solve this. This is just to differentiate and show you the order of how things can be, so you don't confuse yourself. Now, we have 7x squared plus 5x plus 13 over the quadratic equation plus then a linear factor. So we still follow the same principle of how we solve usually. So we take the LCM. So what we have here is x squared plus 2 and x plus 1. So when we divide, so we have ax plus b into x plus 1, right? Plus c into x squared plus 2. Like I said, we equate this with the numerator as equivalent expression plus 5x plus 13 over x squared plus 2 x plus 1. So what we need to do is equate both numerators. I get it now. So we say equating both numerators. So we have, so let's bring back this expression this side and this to this other side. So we have 7x squared plus 5x plus 13 is equivalent to ax plus b, that's x plus 1, plus c into x squared plus 2. Now, so like we did earlier, we have to look at the expressions and see what numbers we can apply. Look at both expressions here and see what figure we can apply to cancel out a section of the of what we have written down here. So in this case now, I can see that if I add the negative 1 here, everything here will be cancelled. Then I can solve for this section of the expression. So let's do that. Let's make x minus 1. So when x is minus 1, so we put it from in both sides of the expression. So this will become 7 into minus 1 squared plus 5 to minus 1 plus 13 equivalent to, so this expression, if we put 1 here, minus 1 here, this will become 0. So I don't want to write that out again. But let's now focus on this area. We have c into minus 1 squared plus 2. So when you expand this now, you have 7 minus 5 plus 13. This is equivalent to, when you open this now, that's going to be 1 plus 2, that's 3. So you have 3c. 3c. So when you take this, say 7 minus 5 is 2, 2 plus 3 is 15. So you have 15 equals to 3c. So you divide both sides by 3. I get me now. Divide both sides by 3. You have, so your c equals to 5. So we have gotten one side of this particular expression. The next thing we need to do is to expand this expression. To get the value for a and b, I guess now we need to expand the right hand side of this expression. So let's go on and expand this side, then we'll make it equivalent to this side. So let's still do that. So we have 7x squared plus 5x plus 13 is equivalent to ax squared plus ax plus bx plus b. When we expand this also, we have cx squared plus 2c. Before I go on, I need to rearrange this side of the expression. Let's rearrange it, then we're going to move to the topmost part of the board to continue. So let's rewrite this expression again. So we have 7x squared plus 5x plus 13 is equivalent to ax squared. Then we have cx squared plus cx squared, right? Plus cx squared. Then we have ax and bx. So plus ax plus bx, and b and 2c. So say plus b plus 2c. Now when you look at this now, you know that this expression represents this. This expression is equivalent to this, and this expression is equivalent to this. So we are going to be picking, since we already have the value for c, that will make us easier. We can use either this or this to get the value for, since we are looking for the value of a and b alone, so we can work with this. Let's pick it out this to start with. So now you know how we have arrived so far. So let me just create a little space here for us to work to get the remaining part of our solution. So we have, now we are going to be comparing both sides. Now let me pick the third part now. I already said that this ax squared plus cx squared is equal to this based on the expression of x in both sides. I get me now. So let me pick this now. So I can say 13 is equivalent to b plus 2x, b plus 2c, sorry, plus 2c. And recall that our c is 5, right? So I can say substitute c equals to 5 into the expression. So we have 13 equals to b plus 2 into 5. So you have 13 equals to b plus 10. So your b will be equals to 13 minus 10. So b equals to 3. If we pick this expression also now, equals to 7x squared. So 7x squared equals to ax squared plus cx squared. X squared is a common factor here, right? So we can say this is 7x squared equals to a plus c x squared. Well, let's put a plus c into the bracket. We have x squared. X squared can cancel out x squared, right? So we are left with 7 equals to a plus c. And recall that we already have c as 5, right? So we say this will become 7 equals to a plus 5. And when you take everything, your a equals to 7 minus 5, and the value of a is equals to 2. So we have obtained the value for A, B, and C for this expression now. So if we are going to rewrite that into the equivalent partial fraction format, we are going to have ax plus b, and a is 2. So we say 2x, b is what? 3. 2x plus 3 over what? X squared plus 2 plus c is what? 5. You say 5 over x plus 1. X plus 1. So let's put this in brackets. So this is the equivalent of this what? 7x squared plus 5x plus 13 over x squared plus 2 and x plus 1. Yes. So I believe that we have satisfactorily completed this question. I want to go through again. If you think you don't understand at the first time of watching, go back again and see how I've applied it to solve this particular question. Remember that you only follow this format when you have a quadratic expression that is not factorizable. If you can factorize it, you don't need to go through this process. I get it now. We are dealing with quadratic expressions that are not factorizable, so we use this process to solve it. I get me now. So I look to get your feedback, get your reactions. Please do comment in the section of the video, and share with your friends, and let me know what you think about what you just watched now. Please subscribe to the channel. Let's grow together, and I'll be there to give you important tips for you to succeed in examination. So thank you so much today.